Guys, I hope you're doing fantastic once more. Today I have this question from November 2016. It's a grade 11 question, but then it's also relevant to grade 12. It's a mathematics paper 2 question. Okay, cool. Now, it says that in the figure below, acute angled triangle ABC is drawn having C at the origin. So we have C at the origin right here. And then we also have A at the x-axis, and then B it's at its particular place right there. Now, from this statement over here where they tell us that in the figure below, acute angle triangle ABC is drawn having C at the origin, we are asked to prove that C squared equals to A squared plus B squared minus 2AB cos of C. For those of us who don't know, this is the cosine rule. We are asked to prove the cosine rule. Right. So now, here's what we're going to do for this cosine rule over here. We are going to draw a height from B going all the way to the base CA. Let me just draw it properly. Right. So this is going to be at 90 degrees. That's the first thing that we do. We call it H, the height. And then the angle, or rather the side opposite to the angle A, is going to be small letter a. Right? And then the side opposite to C is going to be small letter c. While the side opposite to angle B, this is our angle B, it's going to be small letter b. Right? So that's the first thing that we do. Let me just bring those things back. Now, what we are going to do in this particular situation is that we're going to apply Pythagoras. But then before we apply Pythagoras, because now we're going to have this side over here. Let me call this side CT. Right? So that I can just be specific on which triangles I'm referring to. Let's go in triangle BCT. Triangle BCT, I'm going to do Pythagoras. So it's going to be A squared, that's my hypotenuse, equals to H squared. And then this side over here, which is called CT, just going to call it CT. But then let me just call it X for lack of a better wording. And then this one over here, I'm going to call it B minus X, because remember the entirety of this is B, right? From C all the way to A is B. So if from C to T is X, it means that from T to A would be B minus X. Right? So implying that in this triangle BCT, I'm going to have A as my hypotenuse, which is A squared, then H squared, then plus X squared. That's Pythagoras. Okay, cool. Now I head over to triangle BTA. BTA. Going to perform the same thing, perform Pythagoras. It's going to be C squared. C is my hypotenuse, equals H squared. And then I'm going to have plus B minus X all squared. This is still Pythagoras. Right. So now, in this equation over here, in this Pythagoras, in the triangle BTA, I'm going to make H squared the subject of the formula. So it's going to be C squared equals to, but then before I make it subject of the formula, let me just simplify this. It's going to be B squared minus 2BX plus X squared. Then I'm going to take these things over to the other side. So it's going to be C squared minus B squared plus 2BX plus X squared equals to H squared. All right. And then I'm going to take the same h squared, but then now represented by this, and I'm going to substitute it in this equation over here. So it's going to be a squared equals to, instead of h squared, I'm going to put the entirety of the c squared minus b squared plus 2bx plus x squared. And then also I'm going to have plus the x squared there. Okay, simplifying this, I have a squared, c squared minus b squared. A little error was made over there, I can see. Let me just take you back. If you notice over here, when I took these things to the other side, the certain things that must change in terms of that sign, whether they are positive or negative. So I didn't account for that, which is going to cause a whole lot of trouble. The b squared, when it goes to the other side, it becomes minus b squared. The minus 2bx, when it goes to the other side, it becomes positive 2bx. The x squared, when it goes to the other side, it becomes minus x squared. Then this is going to be our h squared, right? So now I can finally replace this h squared over in that particular equation that I found in the first. So it's going to be a squared equals to, instead of this h squared, I'm going to put in the c squared minus the b squared plus the 2bx minus the x squared, and then I have this x squared that follows it as well. Okay, cool. Notice that this minus x squared and this positive x squared cancel out. So I'm left with a squared equals to c squared minus b squared plus 2bx. Now remember, I need c squared as the subject of the formula, right? So I'm going to take all these things to the other side. So it's going to be a squared plus b squared minus 2bx equals to c squared. I've taken these things to the other side, I'm left with c squared. But then now notice that over on what they wanted me to prove, I have the a squared. Yes, I have a squared. I have the b squared. Yes, I have the b squared. The minus 2a, I don't have it. I do have the b. Yes. So I'm left with the cos of c and the a. Right. So what I'm going to do is that, because I'm left with a and c, cos of c, I'm going to go into this triangle over here. The triangle BCT. Right. In triangle BCT, I'm going to say the cos of the angle C is adjacent, which is my x, over the hypotenuse, which is A. Now, making x the subject of the formula, multiplying both sides by A, I have A cos of C. That's going to be my x. I'm going to go back on this equation over here. Just write it over here. I'm going to have a squared plus b squared minus 2b. Instead of x, I'm going to replace with the a cos of c. So it's going to be a cos of c. This entire thing, remember, it's equal to c squared. Now, simplifying even further, I have a squared plus b squared minus 2b times a cos c becomes minus 2ab cos of angle c. Now I have proven my cosine rule.